Hello and welcome. I am test solving a case today. It's called The Matrix and it's by Filip Krerowicz, whose name I'm very likely not pronouncing correctly, but I asked the internet for help and it was very confused, so did what I could. Okay, I'm going to start my timer and just see what happens. Welcome to the matrix, or rather, a matrix. In math, matrix is a regular array of numbers or other mathematical objects arranged in row and column. In the sheet arrays, you will find a 100 by 100 grid containing multiple smaller arrays, along with a diamond marker indicating a 1 by 1 array. Note that there are no other 1 by 1 arrays other than the ones that contain a marker. For clarification, whenever the question references a grid, assume it's asking for a whole 100 by 100 area to be tested. When asked for an array, assume it's asking for smaller chunks of data, smaller arrays. 7 levels, 20 questions each, 5 bonuses. Okay, let's dive on in. Count how many times a character appears in the full 100 by 100 grid. All right. I see. So this is made up of... Huh, interesting. Wonder how you made this data. Oh, and it's already named grid. Hooray, thank you. So then hopefully we can just say countifs grid is this. And indeed we can. Oh, that's going a little slowly. He did mention this file has a solve in it and that it might get a little resource intensive toward the end. So I guess let's see how we go. I might have to delete some of this stuff over here. But for now we'll try and carry on. Count how many arrays have a specified dimension. Interesting. How might we do that? So a couple of thoughts. One is formula text. What will that return? Right, that appropriately throws errors where there aren't any. Okay, so I guess one option, feels like it might be desperately slow, but one option would be to say map grid formula text of grid, or actually we can just say is text, formula text of grid, lambda ab1, just, sorry, formula text of this, and if I say is text, yes, good, that's what I wanted. Okay, so then lambda ab, we're going to say if b, then I guess we could do something like rows of a hash and slash and columns of a hash. For a level 2 and for something marked easy, I feel like I must be missing an easier way to do this, but anyway. Okay, so sorry, that's the if, then the value if false, we'll just say NA. Then I want to call that with a 3, and then I want to let A be that, and I want to group by AA rows 0, minus 2. So we've got 62 2 by 1 arrays, 57 6 by 1 arrays, and so on. So now it should just be a case of VLOOKUP this and this in here, lock 2 0. And it is. Cool. Okay. Count how many arrays contain this. Oh my word. Note, count all instances of the character. If you're looking for 1, then you can find it in 1, 31, or 11. Twice in 11. Do not change the data types. Oh my word. How? How on earth are we doing this? There's got to be some systematic way to think about it, but I don't know. This case is going to get hard fast at this rate, but I guess we can do something like this again. Yeah. Okay. We'll take this. This is going to be very resource intense, though. So we're going to do the map, but this time what we're interested in is, have I imported my lambdas? I have not. I should import my lambdas. Okay. So count awk, a hash by this. We're supposed to be case sensitive, insensitive. I'm assuming insensitive. So say sum of count awk of that. Otherwise 0 is fine, I suppose. And then we should just be saying sum of that. Sorry, no. So I'm going to say minus minus, that sum is where's the end of that? No, this. Oh, count awk, yes, greater than 0. Otherwise 0. So I want to count it once. That does give 65, okay. All right, level 4, medium. Now it's time for a little magic. A square is called a magic square if the sums of the numbers in each row, column, and both main diagonals are the same. This constant sum is called a magic constant. Refer to the figure on the right for an example of what a magic square looks like. Now you need to find all the magic squares that are in the grid and return their magic constant, starting cell of the magic square, dimensions of the magic square. In ascending order, my magic constant. The answer should be formatted magic constant starting cell dimension 614. Note there are 21 magic squares in total in the grid. The first one is used for example 4. The smallest magic square is 3 by 3. Magic squares are standalone arrays within the grid. Okay. Ooh. Okay, so I'm wondering if there is a more intelligent, flexible, scalable way to operate on all the arrays, but I'm going to keep going like this for now because I can't think of anything better to do. So we're going to map grid and isText, blah, blah, blah. We're going to say if B, and if B is, then we're going to operate on A. And the operation on A this time is going to be, well, first we're going to say if rows of A hash is different from columns of A hash, then we return NA, because I wanted that to be filtered out. So now we've got that it is a square. So now we're going to say if so I guess we'll say let main D be sum of munit rows of A. Actually, let's do dimension can be rows of A hash. Main diagonal can be the sum of munit of dim times A hash. The opposite diagonal can be sum of munit of dim times flip A hash just in one direction. Then the R sums be by row A hash sum, and the C sums. Let's see, the row sums are going to be a column, so then I'll do to call of by call A hash sum. So then I want and B stack op D R sums C sums equals main D. So, starting cell, yes, fine. Okay, so then, so we're going to say if all of that is true, then I want to return all this nonsense, which is main D, which is the magic constant, and and slash, and address of row A, column A4, and slash, and dim, and x, and dim. Otherwise, NA. Close, 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 close until the cows come home. We get some huge grid, then we do call that with 3, and hopefully that'll give us 21. No, that seems to be giving us rather more than 21 things. Bother. What else is it giving us? False. Ah, okay, so there's some if that I didn't close out. Where are we? So this if says logical test, value of true, value of false, fine. Then this if in here says logical test, value of true, value of false. So where's the false coming in? Oh, it must be this outer one. Sorry, if B, this one I think probably never completed. Yes. So otherwise NA. Now we got 21, that's good. Then we want to let all be all that madness. And then I want to sort by all by the magic constant, which is the start, which is text. Text split actually is fine, on all by slash times 1. Oh, hey, it actually worked. Okay, level 5. The magic is gone now. In all seriousness, magic is never gone. Embrace the happiness in your life. We'll be dealing with a maximum water in a container problem. The problem is as follows. Given an array where each element represents the height of the vertical lines, find the maximum amount of water that can be contained between any two lines together with the x-axis. I think that this is like the first problem from Leet Code. I have a memory of reading it there. And finding a very neat solution, which I didn't find by myself. What is required of you? Find the part of the grid indicated by the starting cell and the dimensions of rows always down and columns always to the right. Change these markers to 0 and everything else to 1. Sum it by column. This will give you the height of each of the vertical lines. Find the maximum water that can be contained within. Calculate as width inclusive with heights. Width inclusive with height. Okay. Times the lower of the height of the two vertical lines found. It is always a rectangle. Do not tilt the container. Okay. So so on a 2RC ref of this, then I want to, so that plus the rows minus 1 times a million plus the columns minus 1 should give me the reference for the right cell, and then we'll to add that. F8, good. Then I want A1 and colon and that. And then I want 2ref of that on grid. Good. Then I want that equals this diamondy doodly thing. Then I want to bicol minus minus of all that sum. So these are, is the what? That's, no, what? Oh, sorry, the markers are 0. Okay, fine. So it's bicol 1 minus that sum. So we get 7, 7, 7, 6, 8, 8. Good. So the maximum container you can make between column is between column 1 height of 7 and column 6 height of 8. So let's see. Yeah, the number of columns can get large. So I remember that there is a neat, efficient way to do this, but it's also recursive and a little bit complicated. Let's see, the biggest number of columns is 47. I think I might go the way of per column on this, just brute force it. Okay, so let HGHT's heights be that. Then pix can be per column from these many columns to combinations. Just give me pix for a second. Yes, 6 different values, good. So then I want, and so what am I returning? I'm returning the area and the number of the right vertical line. Okay, fine. So then I need a by row. By row of pix. We're going to say lambda row. So we're going to return the area and we're going to return the right vertical line. Okay, so that is going to be, the area will be, I guess, sum of row times, minus 1, 1. So subtract the first one, add the second one, plus 1. That's the width, times the min of index in HGHDS by row. Okay, that's the area, and then I want to h-stack that with the right, so that's going to be index by max of row. So many closing brackets. Okay, and then the largest of these is indeed 42. So then we want to sort that by the first column. Sorry, by the first column descending. Sort where here. 1. Good. Then we want to take from that 1. And then we want to join with a slash. All of that. 42.8. No. Oh, right. Sorry. So we're not looking for the height of the ending column. We're looking for the number of the ending column, in which case it's not index heights by the max. It's just the max. Cool. Oh, got a value error here. Oh dear. Why is that? Okay, so let's call this out. I did a lot of steps in one there, but never mind. Let's do HDHDS. Value. Wow. Oh, did this go out of bounds? So presumably that means the 2ref is erroring out. Let's see. Yes. Okay, so let's take the toAdd bit. As far as here. That down to the end. That sends you to AW101, which is indeed out of bounds. Okay, so I'm going to just highlight that and then change it to 18. And now it says I'm wrong. Okay. AJ83. AJ83. And we want to come down. Yeah, so let's come down 19. Okay, I guess it means, no, because then it should just include, okay. The alternative interpretation would be that all of these get taken as being non-empty. Okay. Fine. So then we'll just, instead of grid, we'll do this 2ref on something bigger than the grid by 1. And then it's good. Okay, well, I don't love that, because then you're saying that all these values are contributing, which I don't think they should. Anyway, fine. It is what it is. Okay, level 6, hard. As you can now hold the water easily, let's change the problem to a maximum rectangle. The problem is as follows. Given a matrix filled with zeros and ones, find the largest rectangle containing only ones and return its area. Oh boy. I mean, I can see how to do it with percom, but is there a way to do it more efficiently? Let's see, none of these is huge, I guess. Maximum of 44, maximum of 40, so yeah, I guess I'll just bash it with percom. I feel like there's, I don't know. Fine, I'm just gonna go with the path of percom. Okay, so, I don't want the bicol sum anymore. I do want the 1 minus part. So this is, I guess, gr for grid. So then I'll call this, I suppose, pix x, and I will also want pix y. Yeah, that's okay. That's okay. By that. And then what do I want? Just the value of the area? Okay. So then I want to by row pix x, lambda row x. For each one of those, I want to by row pix y, lambda row y. Then it's going to be sum of index. Ooh, can I do this? Okay. Okay, so I'm going to change it a little actually. I want. I don't think I actually want this. What do I want? What do I want? What do I want? Okay. So pix x could be made better if instead of going between 1 and whatever, it went between the starting cells. So I'm going to say minus 1 plus 2 col of this. And like, go away, I'm not done yet. Likewise, pix y would be better if it went minus 1 plus 2 row. So then let's just label this TMP, put it all in a string, and then show me pix x for a second. And this starts in A1, so that's not the most helpful example. Okay, so here we are. 3 columns, we got 29, 30, 29, 31, 30, 31. Yes, good. Okay. So then, so we're going to index grid by at row, the row number is the y coordinates, at row y, at row x, colon index grid max row y, max row x. And then I don't want to sum that yet. I want to say let rec be that. And then I want sum of minus minus rec not equal to triangly doodly thing, wherever that is here. So that's the score times, yeah, it's not, I'm overcomplicating it, aren't I? I guess I want to say if that sum is equal to 0, then I want the size of the rectangle, which would be range of row x, I think plus 1. 1, 2, 3, 4, 5, 6. Yes, plus 1. Yeah, range of row x plus 1 times range of row y plus 1, otherwise 0. But then, I guess for this, I'll just take the highest of each of these, and on the outside, I'll take the highest of each of these. And then I think that should do it. Yes. I sure will not be finishing this case in 30 minutes. Ooh, that's going kind of slow. I didn't think it would go that slow. Okay, well, it's done. Level 7, very hard. Time to challenge gravity. Now you'll be required to assess how the array will look like after we apply gravity to it. Each column behaves independently. Letters fall down to the lowest available cell, stopped by barriers. The result is what you'd get if gravity acted on everything, while this acted as solid blocks. These do not fall into gravity. A letter standing on that will stay on top of the block and will not fall further. What? Oh, okay, and the numbers go away. Fine. Find the part of the grid indicated by the starting cell, and the dimension of rows always down and columns always to the right. Leave only the letters and markers in the grid. All the numbers should be treated as blanks in the final array. Apply gravity. Return the last 2 rows of the new array. Okay, I think this is not too bad, actually. In fact, it seems completely fine. Okay. So we come back up here again to get our, no, this. Yes. I didn't actually use the GR at all in this data, but anyway, fine. It's still a relevant calculation to bring down here. Okay. So now we just want the 2ref part, not the equals diamond, blah, 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 blah. Then we're going to say, I think this one's going to be much easier than the last level, actually. So we're going to say by call if is error 1 times gr, then gr, otherwise blank, concat. Yeah, simples. So then, are we, yes, concatenate. So what I want is then right of this to, actually, I'm going to say right of, how do I want to do it? Let's do space, space, and that 2, because that way they should all be of length 2. Yes, good. Then we will say mid of that 1, 2, 1. Wait, sorry, closing that in the wrong place. Good. And then if we concat, we get a diamond KT. Yeah, I think that's right. Concat. And then we want to substitute out all the spaces. Sorry, wrong place. Good. Put it there. Okay. Oh, and actually, look. If these answers are, oh, they're all wrong. What? That's not good. Really? That's very bad. What? Okay. I was just talking about how easy this level was. And I was going to get finished in 30 minutes too, and now I'm not. That's disappointing. All right, so we'll call that out for a second and just return gr. Oh no, not that. I want the cleaned up version. So give me this one. Yeah. So then we do the bicol concat of that. Yeah. Oh, sorry. I get it now. I get it now. I get it now. These are not supposed to move. Oh, that makes this maybe a bad example then, but okay. So in other words, I guess if there was a diamond here, letters above that would not come down. Okay, got it. Then it's a little more complicated. I will grant. So we need to figure out which things. I just want to figure out where the last diamond is. And okay, fine. So, fine. So this is the grid we want to operate on. So I'll call that gr clean. Is that then on a bicol gr clean? On a lambda call, and it's going to be the max of rows gr clean. Actually, the number of rows is always this. So the max of 4 minus 2. Sorry, I have 10 minus 2. So in other words, I always want to include the last 2 rows. And if error, x match, diamondy doodly thing. This guy. Should have just made that a named thing. Never mind. Okay. If error, x match that against CL last to first, then 0, I guess. So then that's the out. So then here, let's hang on, wait. One more closing bracket there. So then I want to vstack. Oh, I need to give this a name. Sorry. Calls to kill, I think. So then I want to vstack gr clean with calls to kill. Sorry, rows to kill, obviously. No, this is bad. Sorry. Bloody hell. Yeah, what am I doing? So here I want to kill everything above there. Here I want to kill everything above there. But here, I do not. Ugh. They're complicated. I'm not gonna lie, this is complicated. I guess. Is there a more? I feel like right now I'm just solving for the last 2 rows, but I want to solve the more general question of what happens to the whole thing. And the answer to that is doable, I think. So let's do this. Let's say bicol of this concat. Then let's text split this by that, vertically, not ignoring empties. Okay. Ugh. But you still need. So this cluster of 3 ends up in the bottom 3, but how do you express that? Oy, so complicated. Okay, fine. So then we'll scan. Okay, first things first. I want this to be just going to call it D. Okay, so now we're going to scan this column. That equals D sum. I don't like that that's true. So scan 0, that sum? Yes. Okay. So that's saying they all end up at the bottom, which is fine. Here they all also end up at the bottom. Okay. Give me something a little more nuanced, please. This one, yes. So there's 0, 1, 2, 3. Okay. So then I want to flip this. Then I want to do runs count of that. And then I want to flip it back. So here we're saying this is the 6th, 5th, 4th, 3rd, 2nd, and 1st thing at a count of 0 of those guys. So then I think that we are almost there. So I think we're going to index this by this plus 1. Then we are going to take right of that by this many characters. Not quite. So I don't know, whatever, rept space by 50 and that. And then we'll take the left of that. That is the letter that ends up in that position. Cool. And then we'll just say, just do it over here, if this, which column I started off on, this column, if this equals D, then D, otherwise this. And that's it, I think. Just give me the original column back to compare. Yeah, cool. Okay, so now I have a by-call operation. Oh my god, it's taking forever. But we're getting there. Okay, so lambda CL let I'll call it clumps be text split concat CL by D. Then dcount, that's the name of the function, dcnt will be scan CL, scan 0, CL equals D sum. Then position will be flip of runs, not runc, runs CNT of flip of D count. And just return pause for a second, see if we can get that far. So we're going to call this on this column here. Okay, so now we've made it as far as there. Now we need this bit. And that's fine. Okay, so letter will be left, right, blah, 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 blah. So index is going to be clumps. We're going to index that by dcnt plus 1, and we're going to, from that, take pause. Too few arguments. Bother. Oh, yeah. And give me a letter. Yes, and then finally we're going to say if CL equals D, then D, otherwise letter. Oh, okay. So now, it only took us 3 years. Now, we're going to apply that whole operation, except that bit, no thank you, to this grid clean. I'm going to say by call of grid clean, that big lambda. Oh, look at that. Did everything just fall down? I do believe it did. Yes. Okay, so then we're going to take from that the last 2 rows, and then we're going to concat them. Okay, considerably harder problem than I first thought. There are spaces here. Are there? Looks like there are spaces here. Mid this. 2. Why are there spaces there? I told it to be blank. Oh, right. It's because I've done this. Fine. Doesn't matter. So we'll substitute from here blank, space to blank. Okay. Whew. That was, oh dear. What? It's not working on this one? That's not good. Why not? Why not? Whee. Where else is it not working? Lots of other places. So it must be that the bicall is throwing an error in some situation, I guess. Every time you think you're there. Anyway, this is a doozy, but it is a very interesting problem, so I don't mind. Okay, so gr clean. Okay, so just grab the bicall for a second. Okay, that's erroring out on the ones that contain nothing, I guess. Okay, not quite as bad as I thought, honestly. So let's have it return instead of this. Call that out and return clumps, I guess. Clumps are value errors. Okay. So is it just that it's failing to text split this? Try if error that, then this. Fine. Okay, then make that change up here. I would have thought, hang on, let's just check that. So text split this on 1, for instance. There are no 1s, so it just returns 1. What's the problem? There is no problem. Right? Oh, maybe it's because it's an empty string. Yeah, there it is. Okay. Fine. We could do that and then trim. Would that make it happier? Hard to tell because I'm screwing around with it all. So we'll come back up here. Try that out. Yeah, happy again. Okay. So, oops. All right. Undo that. There we go. Does this now match up here? No. Yeah, seriously? Okay. Just give me the bicall. Again. Why is this A not coming down? Why are these not coming down? What the heck is going on here? This sucks. Bah. Okay. So, go back to calling that out, and give me pause. I don't know. 431, 431, 21, 11. Okay. Give me decount. And 2, okay. Back to me just gr clean for a second. Yeah. So I guess the answer is it's not moving things correctly if there's... But then isn't my decount just 0 all the time and it's fine? Back to the by call one more time. Yeah, it's not good. Okay. So let's have it output decount. Yeah, it's all 0. Fine. Let's have it output clumps. They're all there. Ooh. This is a space W. Why? Why? Ah, sorry. I did not mean to put that there. I meant to put it here. Stupid. Okay. Does that help? I certainly hope so. Yes, that looks much better. Whee, bloody hell. That was a nightmare to debug, but anyway. Yay! At least it worked in the end. All right. Bonus. Whoa, oops. Sorry. Yes, that was my D reference. Got to keep that. Right. Bonuses. How many unique characters in the whole 100 by 100 grid do not convert the data types? So it should be rows of unique of to call of grid. Yes, which character appears the most apart from the at marker? Okay. Example logical bonus E, example large theoretical. Okay. Sorry. So we're gonna most of grid. And yes, sure enough, D is on top. So then we can just index. Actually, no, never mind. It doesn't matter. Index that to 2 will give us the second most common item. Okay. No? Really? Okay. Why not? Oh, sorry. It asked for the character. Stupid. Fine. So we'll index row 1, row 2, column 1. There we go. Okay. How many arrays are there in total without the 1 by 1 marker arrays? Okay. So do we have a 1/1 in here? Or do those error out? I'm not sure. Equals sort. Sort. That. We do not have the 1 by 1s in there, in which case we can just say it's the sum of these, which is 859. Paste with sum. Okay, there's only one size of array that appears exactly 3 times. Okay. XLOOKUP 3 in here, turning from here. I don't know why I make this formula at all, but whatever. And then substitute slash for x. Good. If you treat this marker as a border or limitation of space, what's the largest theoretical rectangle you can make when you have 2 borders? So a corner laid out using the whole 100 by 100 grid. Okay, what? If you treat the marker as a border, it's the largest theoretical rectangle you can make when you have 2 borders laid out. Okay. So I think it's saying where 2 full sides of it are there. Um, hmm. How in the name of God am I going to do that? What is theoretical rectangle make? And the wording confusing, but I think I'm clear what it's asking. So, uh, what am I trying to do? New row. Format only cells contain cell value equal to D. Format. Fill. Black. Step 1, I'm just going to eyeball. Nothing that big, like this, for example. One of the bigger ones that jumps out visually, this. How am I going to find them? This looks big. I'd be tempted to go with that, 16 by 4. Anyway, I'm going to find a way to be systematic about this, but I guess. So, what do I want to do? Okay. I think what I want to do is I want to search from each cell, from each diamond cell, let's say. I want to see how many is the most I can go to the right and how many is the most I can go down. And then I want to take the product of those. And then that will allow for getting the top left corner. And then I want to apply the same thing to it flipped horizontally, the same thing to it flipped vertically, and the same thing to it flipped horizontally and vertically, and that'll allow for getting it from all the different sides. Okay. So, what are we going to say? We're going to say map. We're going to say map. What are we going to say? Bloody hell. I want this to be able to operate on an array, ideally, so that I can just flip it a bunch of times. Don't absolutely have to, though. So, how am I going to do this? My God. This is tricky. But okay, I've spent too long thinking about it now. So, let gr be minus minus grid equals d. And show me gr just for a second. Good. So then, I guess I want to do it by the row and the column numbers. So then I want to say map if this is a 100 by 100 grid, I think so. CV. Hang on. Yes, 100 by 100, fine. So we'll say if start off. If sequence comma 100, then sequence 100. That's my first argument, and my second argument is if sequence 100, then sequence comma 100. Then I want to say lambda A, B. Now let's just do A and B. Okay, so yes, that is my row number and my column number. That's what I wanted. I guess I'll call it lambda RC. Then I want to say what? I want to say R max will be, sorry, let R max be X match, sorry, say if error x match 0 against, we're going to drop from index gr, row number r, column number 0, and from that we're going to drop the first c-1 columns. I'm going to x match 0 against that and subtract 1. And if that is not found, then we have 1s all the rest of the way along, which would mean, let's see, if we're in column 1, there'll be 101 minus c. Okay, and then we do basically the same thing for cmax. If error x match 0 against, so now we're going to index row 0, column c, and we're going to drop the first r minus 1, and otherwise it's 101 minus r, and then I want, sorry, all of this should be if index gr rc, then do this stuff, because otherwise it's totally irrelevant. So then, sorry, what here? Let's say, no, that's the if error. Wait, that's the if error. That, oh, sorry. There's the if error. So then now here, oh no, I have something mismatched. Oh yeah, sorry, here. I'll close this if error. Good. So then I want cmax times rmax. Well, that took a minute, but got there. And the max is 40. But I don't just want that. I also need to know the dimensions. So let's do cmax times rmax, and this, and rmax, I want row by column, I think, yes. So, and this, and cmax. Actually, I might as well make that an x, because that's the format I need to return to. And then on the other side of this, if I want an NA, then I want to call all of that with 3. And I want to let cans for candidates be all that stuff. Then I want to sort by cans by text split cans on dash times 1 in descending order. Do I have my brackets in the right place? Not sure that was right. Yes. Okay, good. So there's the 40 4 by 10. Good. So then we're going to take at of that, and we're going to take, well, just leave it at that for now. Okay, so now that's 1. How do I want to do this? Let's just do it longhand. So take that and make 4 copies of it. Okay, so then this one is going to be flip. And I want to only flip horizontally. This one we will flip, but only flip vertically. And this one we will flip both ways. Feel a little sad not to have done this all in one cell, but never mind. Okay, so there it is, 64 4 by 16. That is, I think, the one that I found by hand 20 minutes ago or something, but anyway, fine. Let's see if it's the right answer. I certainly hope so, because I've been doing this for an hour. It's not. Ah! Rows times columns. So it's the doubly flipped one, which means it's the bottom. Yeah, it is this. Ah, right, right. Ugh. Um, well, anyway, fine. The answer is 16 by 4, but why is my formula not giving that? Because the row max is, yeah, that's actually the maximum extent of the columns, so fine. That should be C, that should be R, and that should also be true up here, except it should not, yeah, should not be true on the two that are flipped the other way. Anyway, fine. Enough yak. I've been going for an hour, so I'm going to stop. But the answer is 16 by 14. 16 by 4, sorry. There it is. Woo! 1250. That was a smashing case. It was very, very difficult. And I feel like these ones especially made me think, well, specifically the memory of seeing the solutions to this on LeetCode, because I know what I remember is that there's like an O of n solution, and my solution here is O of n squared. So in other words, you're testing every combination. So like for 6 things, there's 6 times 5 over 2 different possibilities, but in general for n things, there's n times n minus 1 over 2, which grows like n squared. There is an O of n solution for this, which is basically you start off with the outer 2, and then whichever one of those is smaller, you step in by 1. So like your first candidate would be 1 to 6, and then you'd say, okay, this one is smaller, you step in here, this one is smaller, you step in here, this one is smaller, you step in here, you step in here. But you'd have to go recursion to do that in Excel, and I think it's probably not, I think it's probably not worth the squeeze when these are small. But if this was advent of code instead, then the biggest one of these would be, 10 million or something, and you would have to do it that way. So didn't cover myself in glory on that front. But on the other hand, this was a non-trivial case, to put it in math speak. So I'm pretty happy to have got through it at all on a first go. Thanks, Philip, for that, and hopefully this will be ready to share with the world before too long. That's all I got for today. Thanks for watching. See you next time.